All right, welcome everyone. Really appreciate you joining today. I'm Michael Banta, and I'm the VP of Product at Cloud Institute. Now, Cloud Institute is a cloud coaching and training company helping IT professionals and teams learn new skills and even earn many cloud certifications. And we believe training is only successful if the skills you learn through our training programs transfer to the workplace and actually help you achieve your goals professionally. And that's why all of our training products include access to personalized one-on-one coaching with cloud experts. And we have a whole swath of cloud experts across AWS, Azure, GCP, and others. Now, today, we're giving away one Google Cloud Certification Bootcamp Pass, which includes 34 hours of self-paced training, 2 hours of that one-on-one personalized coaching to prepare you to earn the Associate Cloud Engineer and Professional Cloud Architect certifications from Google Cloud. This is a $500 value, and we're going to give it away for free. If you're interested, just drop a comment or a question in the chat, or even send me a message and you'll be entered to win. Now, today, we are presenting day 1 of 2 days for a crash course to help prepare you for the GCP Associate Cloud Engineer exam with Prerit Munjal. And Prerit is wicked smart dude. He is a Google Cloud Platform architect, developer, trainer, consultant. He knows almost everything there is to know about Google Cloud. And he has 8 Google Cloud certifications himself, as well as 14 Microsoft Azure certifications. So he has tons of firsthand experience with certification exam preparation and taking the tests. We're thrilled to have him here to share his knowledge on how to earn this really popular and really valuable certification. So with that, I will turn it over to Prerit. Take it away.
Thank you, Mikey, for having me. Hi, guys. So today's agenda is compute and infra services for Google Cloud. Let me know if you can see my screen. Yep. So today's agenda is about Associate Cloud Engineer certification. This is one of the most valuable certifications from the beginner's perspective. So let me tell you something about this certification. This certification costs you around $129, and you have to face 40 to 45 questions. You have around 2 hours of time frame to solve all these questions. Apart from these question stuff, you will face two types of question. One is multi-select and one will be multiple choice options. That means that it is similar to other competitive exams. You will be given four options in each question and you have to select one. And the second criteria or the second type of questions you have is that you will be selecting multiple options in a particular question. There will be no case study in this entire certification, as well as you will be given there will be no hoodies or swags from this certification, as this is the associate cloud engineer. It is one of the most basic certification. So let me start with today's agenda. Today's agenda will be about infrastructure services. Apart from data, we will be covering all the services. We will be implementing some of the services using the hands-on experience on Google Cloud Platform. Theory will be there. I will be sharing some key topics or key questions in between, which will be directly coming into your examination. And yeah, let's get started. First thing first, what is cloud? I hope that most of the people are beginner, so they don't know even the meaning of cloud. Just imagine cloud as a park, as a amusement park, where you just pay for the ticket and go for various rides, various services, have your buffet and all that stuff. Similarly, cloud is a compute park, which offers you services like compute and data services, and you just have to pay a very small amount of money. Um, Basically, there are multiple advantages of Google Cloud. There are multiple vendors like AWS, Microsoft Azure, Google Cloud, Oracle, IBM, and much more. But Google Cloud is really growing at a very fast pace, as compared to the previous year growth. As of now, Google Cloud has two-digit market cap in the cloud industry. Previously, it was just one digit. It has now rose to second digit. Apart from this market cap thing, Google Cloud has also collaborated with multiple giants like Mahindra in India, ShareChat for handling their data part. Apart from that, most of the companies like HDFC Bank in India and other big tech giants are using Google Cloud either for computational thing or because of data part. BigQuery is another great big service that only users come to Google Cloud and use that particular service. We will be covering the data part tomorrow in the second part of this bootcamp. Let's get started. So Google Cloud is similar to other cloud vendors, and we can access Google Cloud using four platforms. One is Cloud Console. The URL for Cloud Console is console.cloud.google.com. You can head over to this link and start working on Google Cloud. Second is the Cloud Shell. Cloud Shell is inbuilt into Google Cloud Platform. As soon as you land to the Google Cloud homepage, you can access Google Cloud Shell. Third is Cloud APIs. That is more for developer part. There is no need to think a lot about APIs as of now. I will be covering every part. Just hear me out for the next 30 to 45 minutes. The next thing that you can access Google Cloud with is Google Cloud app. Most of the people don't know that Google Cloud even has an app on App Store and Play Store, but Google Cloud has. Yeah. So, starting with the basics, what is resource hierarchy, and what is all these stuffs like? What is all this about? How Google Cloud is implemented? How Google Cloud is built? Uh, Let me take a simple example. There is an organization, cloudinstitute.io. We have three teams. One is marketing team, one is engineering team, third is the human resource team. So each team works independently. Similarly, in each team we have multiple people working in each team, right? So they are termed as resource in our general corporate world. We term them as resource, which are beneficial and they can add up to the value of the company. Similarly, in Google Cloud, we have four things. One is organizational node, second is folder, third is projects, and fourth are resources. So, organizational node is cloudinstitute.io. Folders are the different teams, the HR team, the marketing team, and the engineering team. Each team are termed as folders because folders are just built to give you another layer of abstraction so that each team can work in a isolated environment. No team can interrupt someone else. It also helps in your billing part, segregating resources. Also it helps in reducing the network overhead and all that stuff. As soon as your network or your company uh, increases the cloud footprint, then rises the complexity of networking, and there is one term known as VPC islanding. I will be telling you more about this term later on. So similarly, coming back to the topic, we have folders in Google Cloud. Each folder has various each folder can each team can have multiple folders, but generally one folder is only assigned to a particular team. And in each particular folder we can have multiple projects, right? The project can be in production load environment. We generally have three environments. One is dev environment, second is test environment, third is prod environment. So think of projects as the different type of environments, because like there are, in a particular team there are particular people, like one will be the front end guy, second will be the back end guy, third can be the QA, fourth can be the A or AB testers, another various type of users we have, various type of resources we have, right? So different environment can be configured in different projects, and in projects we can have multiple resources. Resources are nothing that are a part of Google Cloud family. The resource can be compute engine, it can be Kubernetes engine, it can be cloud run app engine, anything in Google Cloud terms is termed as a resource. So this was about resource hierarchy. In Google, in particularly talking about the certification, you can have a question like this. You will be given four options, and you will be question will be framed like this. A team is going to be created, and you have finance team, you have marketing team. So which particular hierarchy will you assign to the HR team? So you will just pick the folder term, because you can't assign a big organizational node to just a particular team. Also, giving access to a very small project to a particular team is like not useful. It is not scalable. Team won't have a free space to work on. So similar to this question, you can like think of in the Associate Cloud Engineer certification. The next thing is billing and pricing calculator. This exam is fairly difficult as compared to the other examinations of different cloud vendors like Azure Administrator or AWS Cloud Practitioner. This is fairly hard examination, so hands-on experience is really must. You before even attempting this certification, you go to the cloud console.cloud.google.com, create an account over there, do some hands-on experience, and don't be afraid of the billing part, because when you go to the Google Cloud homepage, they give you a free tier account that gives you $300 of credit for 90 days. So this is about billing. Google Cloud won't charge you even single penny for 90 days unless you forget to delete some resources, because in lab environment and in working in real life, there is a very big different environment created. In labs, all the crons are running at the back end, they delete the resources, they give you particular permissions. But in real life, you have to create your permissions yourself, you have to deploy the infrastructure yourself, you have to delete the infrastructure yourself. So give more emphasis on the hands-on experience. Second thing is go for pricing calculator. One For associate cloud engineer, you can expect one question around pricing calculator. There is no need to learn, there is no need to cram all the pricing of each services, because pricing keeps on regulating. Sometimes cloud run pricing will go up, someday it can go down. So there is no need to cram those, but you should be able to work with the pricing calculator. As soon as you will go to the production grade environment, you need to provide some POC as well as the billing section. So you need to be comfortable with the Google Cloud pricing calculator. The next big thing is VPC. Before even getting started with infrastructure, we must know what is VPC. Similarly, there's a very good example that I give in my other sessions. VPC is just like a home, right? Home is like we all live in a home. So similarly, there is a home in Google Cloud, that is VPC, that is virtual private cloud. So one very good thing about VPC in Google Cloud is that it is global by nature. So what's the advantage of it being global, right? Um, May it be regional, may it be zonal. What do I have to do with it? So, for example, your user base is in India right now, and your another user base is in US right now, and your third user base is in Australia right now. So if the VPC was not global by build, Google Cloud purposely build it globally, global by build. So if it was not global by nature, you must have built a VPC in US, a VPC in India, and a VPC in Australia. And in order to make the VPC talk to each other, or in order to make the data transfer from one VPC to other, or collaborate all the data, you must have used VPN. Generally we would have used VPN, or we would have used VPC peering, which ultimately would have added to a little to the network overhead, right? And the major advantage of making VPC global is that your services, there is no need for you to define all the different zones, or all the different regions, or divide your VPC into multiple VPCs and then let them talk to each other. There is no need for you. Just create a global VPC and create subnets like we do in networking. We have CIDR ranges, we have IP blocks. So we divide particular regions according to blocks, and we deploy the resources into them. And all the resources deployed in that particular region or particular IP range will have that IPs of that particular range. So this is about VPC. This is the advantage of it being global. It has reduced your networking overhead significantly. And next question is, do all the services need VPC? The answer is no. There are many services that do not even require VPC. For example, BigQuery, when you build a data set, or when you build a table, you don't need to define VPC. So there are not every service require VPC for the creation. Only the services that are built on Google Compute Engine, or Google App Engine, or Google Kubernetes Engine require VPC. uh, the next thing is, what is subnets? Like I talked, in big organizations, they have very large chunks of IP addresses, as IPv4s are very short in number. So every organization need to conserve it or use it very precisely, so that they don't even waste one IP. So for that part, we divide, if we have 10 IPs, so we will assign 5 IPs for US, 3 IPs for India, and 2 IPs for Australia. That is the simple working of subnets. And yeah, next thing is VPC. What are VPC flow logs? Basically, these are turned off by default, but the major use is that if you feel that there is some data exfiltration, or there is some extra package, or some packet is missing, or you think that there is some man in middle attack, or you think someone is doing your data is going somewhere else and not going it where it was supposed to. So for that use cases, we use flow logs, but it is recommended to turn it off, because it will track all the incoming and outgoing data from your VPC. Uh, so it will be it will create a huge number of logs, and which will ultimately lead to more storage, and more storage means more billing. The next thing about VPC is that I will be covering all the networking topics here itself. The next big thing is, what is traffic, and what are the types of traffic. It is a very basic building block of your GCP foundation. So what is traffic? Traffic is nothing, the inflow and outflow of packets. At the end, the data is divided into fragments. Generally, we term the uh, traffic as packets of data. Data is divided into packets and sent over to transport layer, network layer, all that layers. We term it as traffic. Traffic is of two types. One is ingress, one is egress. And traffic is a very relative term, to be true. The same traffic can be ingress for me and egress. Like, it is totally based on your perspective. Ingress is the traffic going inwards, coming inwards, and egress is going outwards. For example, I throw a ball at you, and the same ball is egress for me because it's going outward, but the same ball is ingress for you because you are going to catch the ball. So the traffic term is very relative. In Google Cloud, we talk about traffic in terms of VPC. If some traffic is coming towards VPC, that will be ingress. Some traffic that is going outwards of VPC, it will be egress. By default, all the ingress traffic is blocked by Google. There is no firewall rule to allow all the traffic. Uh, as soon as you create a as soon as you log into your Google Cloud account, a default VPC will be created along with four firewall rules, namely default allow SSH, default allow RDP, ICMP, and I think TCP. So only four firewall rules are created by default. Rest, your traffic is blocked, and yeah, I will be covering two firewall rules as well. Now the next thing is, what is RFC 1918? A very very confusing topic among all the beginners. People often get confused. What is this 10.0.0? What is this 10.168? What is this? What is why we are always using this chunk of IP? So when the US military or the US organizations were creating IPv4s, they didn't even know that this will be the next big thing among the internet in the internet era. So previously, like still till now, the US military holds the biggest chunk of IPv4 addresses. But later, as the number of users grew and the number of devices grew, they realized that there isn't that we will run out of IPv4s one day. So the only like we till then they started working on IPv5, IPv6, but most of the devices were then compatible with IPv4. Still now, the industry is not yet ready to transition to the IPv6, because like most of the hardware will be changed, most of the softwares will be changed. Till now, they are not ready to shift to IPv6. Then the organization that built the IPv4 realized that we need to conserve the IPs. So then they blocked three CIDR ranges. Namely, you can see it on the screen: 10.0.0, 10.255, and these three ranges were reserved by them and were named as RFC 1918. So what is RFC 1918? These are the three CIDR blocks that are reserved for a particular for private use cases. Anybody in the world can have same usage, but nobody outside can ping you. For example, I am using the first CIDR range, and you are also using the first CIDR range, right? We both are using the same CIDR ranges, but you can't ping into my network, and I can't ping into your network. So this was the use case of RFC 1918. Similarly, if you check your phone and type on the Google, what is my IP, your IP will surely be belonging to these three IP ranges. Only your router, to be specific, your router has the public IP. So in order to conserve your IPs, uh, so uh, it works basically on CloudNet. I will explain what is CloudNet later on. So it was the main major funda to reduce the consumption of IPv4s by the time. The second thing is, what is IP addresses? There are two types of IP addresses. One is internal and one is external. Internal IP addresses that do not cost you. They belong to the same CIDR blocks, the above that I mentioned. The external one can belong to anything, like it can be 35.34.35. It can be anything. And Google Cloud also offers like external IPv4 addresses, IPv6 addresses. Uh, and also a point to note that if you just reserve a static IP address and don't use it, you will even cost more. Google will even bill you more if you don't even use it. If you have just reserved it and have not used that particular IP address, Google will charge you a lot. I think it's $7 per day. So this was about IPv addresses. Yeah. One more thing. What is the term ephemeral or ephemeral? People often pronounce it in the two ways: ephemeral or ephemeral. So in the top address, when you create a compute engine VM, you will find that it is ephemeral IP address. By default, it is ephemeral. You can assign it a static IP address as well, but by default, it is ephemeral. Most of the virtual machines, all of the virtual machines created in Google Cloud are ephemeral by default. You won't be having a option. You will be having an option for it to be static, but by default it's ephemeral. The meaning of ephemeral is that as soon as the virtual machine shuts down, or as soon as you delete the virtual machine, or as soon as you suspend or restart the virtual machine, the IP address will be changed. For example, now the IP address is 1.1.1.1. As soon as you restart your virtual machine, the IP address would be anything. It can be 2.2.2. It can also be 1.1.1. it is very rare to see that you are assigned the same IP address, but you can be assigned same IP address based on your luck. So this was about IP addresses. The next thing is CloudNet. Yeah, Google Cloud offers CloudNet. It is basically network address translation. It is used with the cloud router. I will explain what is cloud router as well. CloudNet is basically used for example, you want your virtual machines to be private by nature. Private means they should have only internal IP address, but you still want your virtual machines to be accessible through to internet. So for that reason, we can use CloudNet. We can attach our virtual machines with CloudNet and let the IP address of CloudNet talk to internet gateway and give you some resources. So there is no hard and fast rule. You can have private IP or internal IPv address and connect to the public internet using CloudNet. The second thing is, what is cloud router? Cloud router is nothing. It is similar to the physical router that you have. uh, it is used for basically, if you have heard of the term gateway protocol, that is used for BGP sessions and all the dynamic routing part. That is out of the scope of the certification. Cloud router you don't have to cram. CloudNet you don't have to cram. I'm just building the basic blocks of your Google Cloud Foundation so that you can go for professional cloud architect as well, and other professional certifications. So this was about CloudNet and Cloud Router. The next thing is, what is firewall rules? Firewall rule, it is similar to your firewall rules created in your Windows or Mac or Linux systems. Just like firewall rules are used to just uh, segment or filter the data and allow only the specific data to your system. Similarly, we have firewall rules in Google Cloud. We have to define various things. One is type of traffic. Type of traffic, I already told you, traffic can be either ingress or egress, and all the type of traffic is relative to Google Cloud VPC. Second thing is the which network you want to bind the firewall to. Second, the next thing is priority. Priority can be between 0 to 65535, where 0 is the highest priority and 65535 is the lowest priority. For example, what is the use case of priority part? For example, you have one firewall rule that is blocking TCP traffic, and has the priority of 1000. Now you again created another firewall rule with the priority of 1, but that allows TCP traffic. So in this case, there will be a collision between both the firewall rules, and the firewall rule that with the highest priority, that is 1, will win this, and all the TCP traffic will be allowed. This is the major use case of priority. There, when you build highly scalable system, you sometimes want that this traffic to be filtered out. You can have just intersection of both the traffic. So in that case, we use firewall rules, priority section. The next thing is direction of traffic. Direction of traffic can be ingress or egress, and the next thing is action on match. You can either allow it or deny it. A simple thing, 0 or 1, on or off. The next thing, after defining the priority, network name, direction of traffic, action on match, you have to define where to apply these. That is termed as targets. And targets we can either apply to all the instances in the particular VPC, uh, or to particular service accounts, because most of the work at the backend is done by service accounts. So you can even apply the firewall rules to service accounts. The next thing is apply the firewall rules to particular tags. You can create your own tag and apply it to various resources, and those resources will be bind to this particular firewall rule. This is about firewalls. You can define ports and protocols. Port, for example, you want to block the traffic from SSH traffic. So you need to define the ingress traffic, type of traffic, deny it, action on match, and then define the port as 22 and protocol as SSH. This is about firewall rules. You can expect one or two questions just from VPC and firewall rules based on this only. Now, the next big thing, the reason I'm teaching networking at the very first thing, very first part is that networking and security are the basic block of Google Cloud or any cloud vendor. Without networking or security, there is no cloud. You can't even think of anything beside networking and security. Uh, these are all the three things: premium network tier, standard network tier, cloud VPN, partner interconnect, cloud interconnect. So, basic thing: what is premium network tier and what is standard network tier? By default, all your services will be transferred on premium network tier. What is premium network tier? All your traffic will be covered through Google's network. Like Google has is why you just, when you type anything on Google, you just get the response that much quick in 1 ms, 2 ms, 3 ms, any ms, you get it very fast. So all your traffic when switched to premium network tier travels through Google's networking backbone, that is Andromeda. So everything is transferred through Google's network. So by default it's enabled, and you will get a little more cost based because you are using Google's network, so you will be charged a little more. The next thing is hybrid connectivity. It is used when you want to connect your data center on premise. On premise is the data center that you have in house, and cloud. As of now, there are five things. One is cloud VPN. Second is interconnects, partner interconnect, dedicated interconnect. Third is the peering, direct peering and carrier peering. Now, this is the really fun part. You will receive five questions based on hybrid connectivity in your certification. For this, you need to have a very good understanding of cloud routers and VPCs. That's it. That's why I taught them in the beginning. Now, what is VPN? Similarly, you have VPNs in your phone, right? Virtual private network. So, what are they used for? They are used to bounce uh, your location. They are used to hide your identity on on the public internet. That is the major two use case of VPN. Similarly, in Google Cloud, we have Cloud VPN. Cloud VPN is used to like your data will be transferred over the public internet, but it will be encrypted using tunnels. Like you will create your own tunnels, and your data will pass through it through encrypted form. Nobody can hack those. There can be no man in middle attack. Nothing can be done to that data. If somebody happens to crack that code, all they will see is chunk of rare random data. So as of now, Google Cloud offers two types of VPN. One is classic VPN, second is the HA VPN. Google Cloud recommends you to use HA VPN, that is high availability VPN. In that, like we have BGP. BGP is out of the scope of associate certification, but on high level overview, just have a look that you are having an organization with the subnet range of 1.1.1./28. So you have a CIDR block of 28. Then after a few days, you receive a lot of traffic, and you think of buying more chunks of IP addresses, more chunk of CIDR blocks. So your previous system was configured based on the previous 28 CIDR block, right? But now you have again purchased more CIDR blocks, more IP addresses. Now you need to reconfigure your system. You need to create your own routes, because routes is a very difficult or very advanced term for this certification. But routes are something that that are pre-built by Google for you. As soon as you create your account, Google automatically creates a route to your internet gateway and all that stuff. Uh, as soon as you coming back to my example, as soon as you buy more chunks, you need to reconfigure your network. You need to create your routes. For that thing, we use cloud routers. Cloud routers are used for this purpose only, and HAVPN is more based on this part. There is no need for you to define all the routes. Everything will be taken care of by Google Cloud. So one is HAVPN, high availability VPN. Second is the classic VPN, and yeah, you can have three types of route. One is dynamic routing. Second is policy based routing. Third is static routing. No need to cram all these. Just have a overview, like if you face something in question like you need to use the public internet, but you want hybrid connectivity between your data centers and your on-prem and Google Cloud, but you want to use the public internet. So the only option for this part is Cloud VPN. Again, if you find any other hint, any other option, like the options are classic VPN or HA VPN. Again, if you find something like gateway protocol, or something like your system is expanding, you need to create your own routes, you need to manage your own networking overhead, then pick HA VPN, and it is also recommended by Google. Second thing is interconnect, and interconnect is uh, like you can think of it like users only shift to interconnect when they are very much sure, that they will be using Google Cloud for next at least 5 years. um, the criteria for interconnect is that you must be very near to the Google's data center. In US we have multiple, US central one, you have US one, west one, you have various options of data centers. So the only criteria for interconnect is like this is not the criteria. We have interconnect divided into multiple options, but for interconnect, if you are much sure that you will be connecting your on-prem to cloud, and also you need a dedicated a private path, a private line of private fiber line, so that you can send your data very safely from your on-prem to cloud, then only pick interconnect. Interconnect is costly at first end, like capex is increased at the very first end, because like companies will be laying down lines from your data center to Google Cloud, and also um, having attaching the V-links, which will be giving you 10 Gbps per tunnel, so per link. So another thing, difference between dedicated interconnect and partner interconnect is that if you are very much close to Google's co-location facility, please mark my term, co-location facility. Co-location facility is a it just think of it as data center. It is very much like connect. It is a facility connected to data centers, very close to data centers. And there is another term called as POPs. POPs is point of presence, that those are not connected to a data center. They are much apart. They are much apart from the real data centers. So there's two terms, co-location facility and POPs. For interconnects, we use the co-location facilities. And if you live near the data center, very much near, less than 10 kilometers or 5 kilometers of radius of, at least very much near to Google Cloud's data center, then pick the dedicated interconnect. And if you live far apart but you still need a private link to Google Cloud, then pick the partner interconnect. Partner interconnect, like from the logo itself you can see that there is one middle line. So middle line is nothing. The middle line is the ISP, internet service provider. We have multiple, like in US we have Verizon, we have AT&T. So service providers have already infrastructure set up, they already have lines. So what they do is they connect your data center to their to ISP, and ISP then connects itself to the Google's point of presence, to Google's uh, what do I say, Google's co-location facility. So this was about interconnect. Interconnect offers a 10 Gbps per link, and you can have at max of 80 Gbps per now. That is 80 Gbps is a very huge number, very huge speed for now. So the next thing is peering. Pairing is not like people often get confused between what is carrier pairing and direct pairing. It is a perfect chart. We will be giving you PPTs after this workshop, and you can have a look over this diagram. So when pairing is required, if you want to connect to Google Workspace, or if you want to connect to Google services, only then you need to pick peering. There is also very much less documentation available on peering. So peering is divided into two parts: direct peering and carrier peering. And if you are near to pop, that is point of presence, you can have direct peering. If you don't live near to the pop, you can have ISP. And one very good thing about one very interesting thing about peering is that carrier peering provides no SLA. In the dedicated interconnect, we have 10 Gbps per link, like Google is offering you this much. But in carrier pairing, there is no SLA, nothing. So this was about hybrid connectivity. Networking is fairly done in this session. Now we will be switching to security. IAM is identity and access management system, access management. So this thing is fairly same in all the cloud vendor. If you know IAM of AWS, you will be like you will face no issues for GCP's IAM. So IAM tells you who can do what on which resource. Simple thing. If you live in a society, or if you go to a gym, you have an RFID card. When you pass the RFID card, the software scans you that you are this person. You have access to this much floors. You have access to the spa and all that stuff. So that is a perfect classic example of IAM. Similarly, in Google Cloud, we have IAM. We just have to define our email ID, group or G Suite ID, any ID, and just define the set of permissions. For permissions or roles, it is divided into three parts. One is basic, second is predefined, third is custom. What are these? So in the beginning, when Google Cloud was created, the tech was evolving. People were still not were very less on cloud. People were still on their on-prem environment. So at that time, Google Cloud built the basic one. It had three things: viewer, editor, and owner. Fairly very basic terms. One is the viewer. By the term, you can see that the person has only the access to view all the resources in the organization. Then we have the editor. Editor means that you can create or do any sort of stuff. Owner is the person who created that particular project. Down the line, when Google Cloud collected the data points from the users, collected the feedback, they created another type of role named as predefined. Predefined was like all according to the user needs. Google Cloud already created, like, one is storage cloud admin, then is the BigQuery admin, then there is some IAM admin, then there is billing administrator. So Google Cloud down the line collected all the data points, segregated different permissions, and collected them to form a particular role. So this was about predefined, but still the tech is evolving. So there is some very unique use cases of users. Like, Google can't create all predefined roles for yourself. Organizations have some custom requirements. So for those requirements, you can create custom roles. You can pick up particular permissions, combine them, and form a custom role, and then apply it to a particular principle. Next thing, what is service accounts? I still remember when I was preparing for the ACE certification, I was still not at the end also. During the preparation or when the exam was coming near, I was not able to recall what are service accounts, because you won't see service accounts working, because service account, you if you create a virtual machine, you will just see it's a virtual machine. Where is service account? I can't even find where is service account. So service accounts are something that works at the backend. By default, two service accounts are created. One is for the um, app engine, and second is for the compute engine. uh, so service accounts are the accounts that work on your basis. Like, they will impersonate you, that you are working, and they do the work for yourself by claiming that they are you. This is very you might have got confused. So a simple thing, they will tell the services that you are there, but they will do the task for you. So still a little confusing. Another thing about service account is that keys are you need to provide keys, and keys are have a life of infinite. They live infinite. They don't expire automatically. So, and also they don't have password. They just have keys. So this was about service accounts. You need to have a fair idea, a high level idea about what are the three types of service accounts. One is user managed, that is you create. Second is default service accounts. I already told two are created. Third is Google managed service accounts. There are services like one is cloud built. So it uses a service account at the backend. For example, there is one if you create a GKE cluster, you create two nodes. So at the backend, service accounts create virtual machines in compute engine. So nearly in every operation we use service accounts. So this is a fair list of the Google Cloud Compute products. Uh, we have App Engine, we have Bare Metal Solution. Bare Metal Solution is just for the Oracle workloads. There's no need for in this certification. Coming back to App Engine, App Engine is by the term you can say that it is used for deploying applications. So you just need to upload the code, and it is a totally serverless managed service provided by Google Cloud. Just deploy the code, and rest will be taken care by Google Cloud. You must be fairly comfortable as it is a boot camp. So we can't cover everything. We can't cover all these commands and all that stuff. So a fair idea what is App Engine. You need to be very much comfortable with all the CLI commands of App Engine. For example, you want to split the traffic between the different versions of App Engine. So you need to deploy. You need to enter a command called gcloud app set traffic, and then splits splits is equal to v1 is equal to zero point 0.5 or zero point 0.3 depending on your use case. So you need to be very much clear. You need to know how to build a Docker image, a Docker build, and then store it to the container registry, and then using that container registry path, just deploy that particular app. So this was about App Engine. Batch. There's no need because it was recently launched, so no need to go over that. It won't be coming in the certification. Cloud GPUs again not a part of the certification. Cloud Run is a part of certification. I will be teaching you in detail in further steps. Cloud Run and GKE. Computation as well. I will be teaching it. Spot VMs, preemptible VMs. I think we are running late, so I must speed up. Very very big thing, what is compute engine? You can expect around 5 to 6 questions. Keep apart the questions also. This is the heart of Google Cloud. Networking, security, and this compute engine. Nearly every service, if you talk about GKE also uses a compute engine at the backend, because compute engine is nothing. They are just like your laptop. Your laptop is used to do compute power, right? It is like I'm currently streaming from StreamYard, so it is using some computational power. It is using some data storage to render my video and send it over to the network, then receiving the video back and uh, giving it in my earphones. So it is using some power, right? Computational or data power. Broadly, everything is using computational and data power. In Google Cloud, the service is compute engine, and in compute engine, we need to define the name, region, because like your virtual machine must be created somewhere, right? Somewhere of the world, it must be there, because you are creating it online, but it must be in a physical state, because uh, by the term cloud doesn't mean that all the computational power is done in clouds. So there must be a particular physical location of that virtual machine. For that reason, Google Cloud asks you for region. Google has already divided the whole globe into regions and zones, except China and Russia. You won't find data centers. Else, Google Cloud has data centers and connectivity over the entire globe. And talking about the region and zone, region, you need to define the region because like Google needs to provision it in the physical form. And for region and zone, you can head over to Google Cloud documentation. Generally, We create resources in US central one, as close as to your user base, because it at the end it will affect your latency. uh, Next thing is, what is machine family and type. Google has broadly classified all the machine types into four types. One is general purpose, second is compute optimized, third is memory optimized, fourth is GPU. Just remember all these terms: compute optimized, memory optimized, and GPUs and general purpose. So by the term, I told you that most of the work is computational and data. Compute optimized is more inclined towards compute power. For example, there is a ratio of processor, like 80% of the processor of the machine will comprise of the computational, and 20% will be of data. Similarly, in memory, it will be more inclined towards memory part. General purpose is was built for general purpose workload. For example, deploying a website, deploying an application. Memory optimized machine family can be used for deploying a database on compute engine. Compute optimized can be used to calculate high precision values. General purpose can be used for applications and website. GPUs can be used for deploying or rendering your photos and videos. This was about machine family. Now, each machine family is divided into series or types. Uh, in general purpose, we have E2, E1, N1. Google has already defined those for you. You just need to. Google has also mentioned the examples you will get for each type of series or type. So for that, you need to pick those and just apply those. There is no need for you to cram all the type of machine types. Just have a high level overview that these are four type machine family types, and from these I will pick one of the machine. Next thing is, what is disk? Disk is of two types. One is boot disk, second is the persistent disk. Similarly, you have your RAM, right? You have your OS. OS is stored somewhere, right? Similarly, we have boot disk in compute engine, and we have persistent disk. For example, you have HDDs and SSDs in your compute engine. You need to store particular type of information that can persist. I told you right in the beginning that ephemeral thing. So as soon as your compute engine is rebooted or restarted or deleted, you will lose your entire data. For you to persist your data for longer duration of time, you need to have uh, a persistent disk attached to it. It can be, as of now, Google Cloud offers three type of persistent disk. One is I can't recall the name, but one is standard PD, another is high performance PD. Google renamed it in these days, but there are broadly three types of PD. Fourth is the service account. I already mentioned the types of service account. Fifth is metadata. Metadata, we define startup scripts and shutdown scripts. Uh, Startup scripts are something like you want the the virtual machine to be started with a PHP configuration. You want it to have installed Apache. You want MySQL to be installed, pre-installed before even you get the virtual machine. So for this purpose, we use startup scripts. Shutdown is also used for similar purpose. For example, you want to have a graceful shutdown. You want the shutdown to be in a particular sequence, like all the data must be raised, then the disk will be freed. So in that we define shutdown scripts. Sixth is the network. Like I told you, VPC is only uh, mandatory for all the services that use GCE, App Engine, or GKE. So as it is GCE itself, you need to define the network. Again, uh, 5 to 6 questions will be from compute engine, and 1 to 2 questions will be from type of discounts. There are two types of discounts generally. One is sustained discounts, second is committed discounts, third is preemptible VMs. So one is sustained discounts, like if you use more than 25% of your computational power or your instances, then Google Cloud will give you some sort of discount that is termed as sustained discounts. Second is committed discounts. It is more of a vendor lock-in thing. You need to tell Google Cloud that I will be using this resources for next 3 years, and can you please give me some more discounts? So you need to pre-configure it, you need to tell Google about this, and Google will give you a very reasonable discount on that. Again, as the number of years are increased in the committed discount, more will be the discount. And in similar to sustained, if you use more percentage of your uh, resources, then you will be given more discounts. Third thing is, what are preemptible VMs? So these are the VMs that are like uh, only use these sort of VMs when you don't want the VM to sustain for long time. For your example, the best example for this type of VM is the batch workloads. You want your VM to run batch workloads, and there is no mission critical thing. For example, if your VM also goes down, there is no harm on your business. For this purpose, we use preemptible VMs, and like they are very much cheap as compared to the virtual machines. Preemptible VMs only have a con that they can be shut down at any time with only 1 to 3 minute warning to you. Google will not shut down it directly. It will give you 1 to 3 minutes of warning. uh, the reason behind giving you preemptible VMs is that, like, you must be thinking, what is the profit of Google Cloud? Because there are whole data center is divided into particular racks, right? Particular servers, particular racks. So there may happen like Google's entire system. It may happen that in one rack there is a single server left, or one or two, three servers are left in that particular rack. So for those purpose, Google thinks that these servers should not get wasted, or these servers should not be misused, not used. So they give you these VMs for very cheap discounts. And if they find like any user giving it for more price, they will take the VM back from you. Generally, it's preferred to use preemptible VMs in the weekdays, not at the weekends, because in the weekends there can be like user generally go to internet and shop on weekends. So there can be some peak hours, there can be some high load. So in that thing, Google will take back the preemptible VMs. And the maximum age for preemptible VMs is 24 hours. Again, computer engine is a very big topic. What are persistent disk? I told you, if you want your data to be persistent for long. What are snapshots? You have Snapchat, right? Everybody has used Snapchat in real life. So in Snapchat, we take a snap, and we store it in our gallery. What does that snap tells us? That snap is just a memory of that particular moment that you have captured, that particular feeling, that particular configuration. Similarly, in Google Cloud, we have snapshots. They are that point in time screenshot of that virtual machine, along with the virtual machine. No, it can be any system, along with the dependencies, along with all the configurations. So snapshots are that thing. The next thing is, what are images? Images, again, the same thing. You can build a image from a snapshot, and a snapshot, and then it can be used to build a disk, and disk can be again attached to a particular compute engine. For example, you want to migrate from one zone to another, you can't do that instantaneously. First, you need to take a snapshot out of that particular machine, then create an image from that snapshot, and then create a disk from that particular image, and then deploy that particular disk to a particular compute engine in another zone. This was about these small things. Like, you won't expect a question on this, but you must be well known of these things. What are these? The next thing is, what are instance templates? For example, you want to deploy a fleet of VMs, maybe 1,000 VMs or 1,500 VMs. So for that scenario, we build instance templates. These are just blueprints. Like, we have blueprints of our house or our properties. For that thing, For our residential complex as well, we have blueprints, right? So for Google Cloud also, we have instance templates. These are just blueprints. If you want to deploy it on like thousands or 3,000, 5,000 VMs, then you can use instance templates. The only difference between instance template and creating a compute engine is that in instance template you can't define the region and zone. Rest you can define it. The next thing is instance groups. Again, to hold multiple types of VMs, we need to have compute engine instance templates, and instance groups are of three types. One is stateless, MIG. MIG is short form of managed instance group. Managed instance group stateless, MIG stateful, and third is unmanaged instance group. For example, we want to have 1000 VM of safe configuration, we will use MIG stateless. If we want to have one instance of N1 standard one of N2 N1 standard 2, and another of E2 medium 2, then we can collab all the VMs and combine them in a unmanaged instance group. Next thing, what is load balancing? Yeah, when we talk about the instance groups, we need to talk about load balancing. There are generally four types of load balancers. One is external load balancer, external HTTP load balancer. Second is internal HTTP load balancer. Third is external TCP UDP load balancer, and fourth is SSL and TCP proxy load balancer. Very hi-fi terms. No need to think more about these. Um, Generally, in the next slide, you can have a screenshot of this. Just cram it or just learn it, because it will give you benefit in long run. You will be benefited a lot. Uh, all the traffic is divided, like we generally have three type of traffic. One is HTTP or HTTPS, second is TCP, and third is UDP. Generally we talk in these traffic terms. So for all the type of traffic, we have configured different type of load balancers. For example, we want to deploy internal load balancer, then we can have internal load balancer. And another thing is that people often get confused: what is SSL proxy, what is TCP proxy, what is this proxy term means. So giving a high level overview, SSL proxy is that, for example, your HTTP traffic is coming inwards your system, but you want your for a HTTPS traffic, there is a like TLS certificate thing coming along with it. So it adds an overhead networking part. It adds a it slow downs the process a little bit. For that part, if you want the certificate to be terminated at the load balancer level, we use SSL load balancer. And we have TCP proxy as well. So yeah, this is about load balancers. You just need to know how to define it. What are the services? What are the backend buckets? How we need to connect those? What are forwarding rules? What is the backend? What is the front end configuration? You just need to have those basic stuff. Generally, load balancer has three things: a front end configuration, that you can define IP addresses. Second thing is the backend configuration. There you can define manage instance group, right? Talked about the instance groups above. Instance groups are nothing, just computational power. And for deploying any sort of website or application, we need to support it with computational power, right? Where will we do the incoming where will we perform the things on the incoming traffic, right? So for that, we need to attach it with the static ID, either the instance groups, or for the static content, we need to connect it with a bucket. And also we can add CDN to it. CDN is content delivery network. It is more for edge networking, edge computing. Or if you want to be more clear, uh, we have edge servers in Google's location. Google has already created some locations around the globe. In that, all the edge servers are there. Edge servers are nothing, they are used for totally caching part. Caching is nothing, just storing your data for temporarily. uh, like the fastest form of memory is cache. So we have, and also caches are very much pricey, so we can't store everything in cache. So Google has already pinpointed the location around the globe, and at that particular area, Google caches all your content. That is called CDN, and uh, all the locations are connected. That entire network is called Cloud CDN. And the next thing is, what is Cloud Armor? Again, if you find any of the term like DDoS, distributed denial of service, if you find some uh, you want something like this, you want to block a particular IP address that you think is suspicious of sending you thousands of requests and slowing down your systems, or your CPU utilization has throttled up, and again like simple stuff related to some DDoS attack or some attack on your system, then just pick Cloud Armor. Cloud Armor was built for this purpose. You just need to define a particular IP address, create a blacklist policy or whitelist policy, and you're done. Again, the next big thing is GKE, Google Kubernetes Engine. If you know Kubernetes, IT will have always a place for you. Kubernetes is the real king of cloud or DevOps. So it is very much deep, but for now I will be covering high level as of now, because I think we are running out of time. Kubernetes was, in some background about Kubernetes. Kubernetes was built by Google itself. It was in-house SRE, and and Kubernetes was going in hand in Google. They were developing their own SRE culture as well as Kubernetes engine, though they don't have any relation in them. Again, the Kubernetes is now open sourced. Google has open sourced it, and it is built on Go programming language. The ancestors or the father and mother of Kubernetes is Borg and Omega. Borg and Omega are still used by Google behind most of their services. For example, BigQuery still uses Omega and Colossus file system. They still use multiple things that they have not open source, but Borg and Omega are the ancestors of Kubernetes and are still in use by Google for their in-house production grade environment. So what is Kubernetes? Kubernetes is nothing. Kubernetes is a platform to deploy your production grade containers, or it is just an orchestration tool for deploying your containers. Because these days microservices are in trend, except for monolith. Monolith are not always bad. Google still uses monolith applications, but these days microservice are on boom. So people, companies or big companies are shifting towards the microservice architecture. For that part, Kubernetes is a really good option to deploy microservice architecture. uh, Again, coming back to basics, what is images and containers? Because previously, a little high level overview of microservice. What are microservices? The entire application is divided into small services. For example, you have a payment, you have an app, Amazon app. You have three services. One is the UI service, second is the image service, third is the pantry service, fourth is the product catalog service. So the entire system is divided into certain categories, and all the services are deployed individually. The major advantage of using or deploying these services individually is that they helps in scaling. So for scaling as well, and other stuff as well. For example, you want multiple teams to work on different environments, you can have used microservice architecture. The next thing is, what are images and containers? Images, similar to your images in a phone, they are used to capture those particular moments. What are containers? Containers are used to run images. uh, like, without containers you can't run images. Containers are, again, you can think it of as a box to transfer the things, like we use when we relocate or move from one place to another. We use boxes to take our things with us. Similarly, containers in Kubernetes are used for deploying the images. Again, there are 5 to 6 components of Kubernetes. One is Kube API server, second is Kube scheduler, third is Kube controller manager, fourth is HCD, database. Next is kubelet, kubeproxy, kubeproxy, and the next thing is docker daemon. So there is no need to go that much into deep, but if you know those, it will be really great for you to learn GKE. Now, key components of Kubernetes. The majorly we discuss about pods, nodes, services, deployments, ingress, config maps, and secrets. As of now, Google Cloud offers Kubernetes engine in two parts. One is standard mode, second is autopilot mode. In standard mode, you need to define all your things. What are node pools, type of machines, and the amount of boot disk, and all that stuff. In autopilot, you just need to define the region. Rest Google Cloud will take care of. Coming back to key components, pods. What are pods? Pods are the smallest deployable units. Nodes are simple servers. What are services? Again, pods are ephemeral by nature. Like one pod can die anytime. For your preference, you can have at max of 110 pods. But one interesting fact about pods, scheduling pods in Kubernetes, is that though you have 256 or near about 256 IP addresses, you still can only deploy 110 pods. Why is that? So one cool fact is that Google has already given you the space to deploy half of the pods, because there may happen that all the pods, 100 pods, can fail and create at once. So for that part, we need to reserve 110 more IPs in advance, in case, in the worst scenario, if sometime all the pods fail, they need to recreate of their own. How they will recreate of their own? There is one mechanism inbuilt in Kubernetes, that is kubectl controller manager, that runs the reconciliation loop, and they will then match the current configuration. If the current configuration is not that of desired, it will recreate the pod. For that purpose, you don't have to think anything. It was just an interesting fact that you can only deploy half the number of pods. Nodes are just the compute engine thing. Just think of that. Services, again, pods are ephemeral. Pods can die anytime. We need to define those and expose those. For that, we need to create deployment are nothing, just blueprint. So for that part, there is much more complex thing like labels and selectors, and then, so let no not go that much deep into Kubernetes as of now. But deployments were built because of this reason, create maintaining the replicas. Then you can't give the IP address of deployments to end user. You need to give a particular IP address. For that part, we have built services. Services are used to expose your deployment to the outside world. As of now, there are three types of services. One is load balancer, second is cluster IP, third is node port. So cluster IP is used for internal use case, internal communication. Load balancer is specifically meant for cloud-based thing, and and node port is also used for facing external traffic. Again, we are humans. We can't remember IP addresses. Ingress is another big term for the Kubernetes thing. When Because we just go to google.com, we don't remember the IP address of Google. Similarly, ingress is used for that part. Config maps and secrets are more advanced topics. That are used for uh, like, by secrets, you can think that it is used for storing some credentials or some very sensitive information. Config maps are again used for passing some URLs without hard coding them. I think we are running out of time, so not implementing those. We will be, maybe implementing the things in the tomorrow's session. The next thing, what is serverless computing? Serverless, as of now, I have already explained what is App Engine. Cloud Function is another good service, that is fast function as a service. So you just need to define your code. Make cloud anything do for you. May it be transferring your um, data from one service to another, or running a cron at particular thing, or checking that what is the sorry, what is the total uh, storage occupied by a particular object. Anything cloud function will do for you. Just write code. Your Google Cloud offers multiple things, multiple languages, may it be Node.js, Python, Go, any language except C and C++. So the next thing is Cloud Run. Cloud Run is similar to Google Kubernetes Engine. The only difference is that it is totally managed and serverless. What is serverless, right? I'm talking about the serverless things, but what is serverless? People often get confused that serverless means there is no server, but without server, with nothing can run. So serverless was the term coined. The real meaning of serverless is that there's no need for you to define anything. I will take care everything, like from data to compute. I will take care of anything, everything and anything. So Google Cloud is the vendor here. So Google Cloud will take care of the everything and anything in computing. And Cloud Run is similar to GKE. Uh, you just need to deploy your code, create a service, and rest Google Cloud will take care. No need for you to define node pool, machine type, region. Region is there, region and zone are there, but no need to define machine type or machines, number of nodes, boot disk, nothing. Yeah, I think yeah, I defined what is Cloud Run. Cloud services, yes. Use cases, streaming, data processing, all the microservices based containerized application basically. Cloud function, yeah, I already told you. Cloud function as of now is offered in generation 1 and generation 2. The recently only generation 2 was launched. The difference between gen 1 and gen 2 is that it offers more runtime. Also, there is like multiple changes to the configuration of gen 1 and gen 2. So you can have a look in the Google Cloud documentation. But for associate cloud engineer, just know what is cloud functions. uh, yep. App engine, already told you, types of environment, standard and flexible. A good thing to share, what are services and version. By default, a service with the name default will be created in your Google Cloud Console, and you need to deploy your application over there first and then create versions. So what are versions and services? Your application can be divided into multiple services. May it be one service can be for the UI, one can be for the product catalog, and each service can be of multiple versions. And like I told you before, you must be fairly comfortable with the gcloud commands, that how to split traffic between the versions. So this was about App Engine. Last thing, monitoring and logging. A really, really interesting topic for every Google Cloud certification. Monitoring, by the name, you can think that you have to monitor the things. Logging means someone or something is writing it down. So for monitoring, you have dashboards, you have uptime checks, you have alerting systems. You need to just create those, and your monitoring part will be done. Just have high level overview. What is uptime check? What is alerting? What are the key metrics like CPU utilization, IOPS, uh, disk IOPS, or any other stuff? Other, like a basic criteria for defining an alert. The next thing is what is log explorer and log router. So log explorer is nothing, big sink, a big storage for storing your logs. You can write SQL queries, or you can connect it with BigQuery. For that part, we need to use cloud. We need to create a sink which will direct all the logs to BigQuery, and then we can have run queries on it. There are four types of audit logs. Please pay attention to all the four type of audit logs. One is admin activity audit logs. It will have the logs for all the admin related stuff. Second is data access, all the data related stuff, who accessed the data and when. Third is system event, for this policy denied. So today's homework or your to-do task is that just just Google it, which type of audit logs cannot be disabled, and also what is the maximum retention age of which audit log. So this is your today's homework. Last thing, Cloud Marketplace, it is a store, like your app store is there. You can download apps. Similarly, we have Google Cloud Marketplace. You can deploy third party applications, for example WordPress, MongoDB, at least various applications have collaborated with Google Cloud, and they have readily available applications are there. You just need to launch it and see for the licensing fees. Yeah, we are open for question and answer.
Yeah, thank you very much, Prerit. That was a lot of great info. So we do have a handful of questions that we'll run through, and in case some folks were not here earlier for some of these questions, I'll go over them again for those who may not have been here. One question was for this cloud certification, the Google Cloud Associate Cloud Architect. What is the pass mark for the exam? And that is
Yeah,
70%. Now,
yeah.
Google may not tell you exactly what score you got, but they'll let you know if you passed or failed. So, is there any other information to add to that point, Prerit?
No, Google will just give you a status of pass or fail. And apart from this, if you fail, you will be given 14 days of cooldown period. Again, if you fail for that attempt as well, they will give you 3 months of cool period. And if you again fail in that attempt, they will give you 1 year of cooldown period.
Okay, wonderful. That's really good to know. Okay, so another question that we had is it easy to move the virtual machine to another cloud provider, or are you tied to Google?
Um is it easy to move? uh, you can migrate those VMs from one uh, cloud vendor to another, but this certification is not at all specific to virtual machine to migration stuff. You just need to be very much comfortable with the Google Cloud services. No migration thing involved in this certification.
Okay, great to know. Um, and how long does the exam take, or how much time do they give you to complete the exam?
It is about 2 hours.
2 hours. Okay,
Yeah.
wonderful. Good. Yeah, that's a pretty long exam. All right. So another question is this might have been related to a specific point in your presentation, Prerit, but one person on
Yeah.
LinkedIn asked if the templates are written in JSON.
No, actually, templates you can define it, but the templates are created using the console as well. You can also create templates using the gcloud command. So yeah, you can use multiple libraries, but for being it simplistic, simple, you can define it using console as well, and as well as the gcloud command.
Awesome. So definitely some flexibility there. All right. Then the last question that we have, and there's an acronym here that I don't seem to recognize, but how does LB handle DDoS attacks? I don't know if that was during a certain.
Okay,
Yeah.
so yeah, yeah, got it. So how LB handle DDoS attacks? So LB Google Cloud will give you fair advantage because your entire traffic will go through the entire Google's network. But to prevent it from attacks, you need to attach a cloud armor with it. You need to create the for example, you have a particular IP address that you think that it is suspicious. This IP address is pinging my virtual machines again and again. Thousands of requests are coming in just a few minutes. So you can create a blacklist, and blacklist policy. You can define an IP and deny all the traffic to it. So you can use cloud armor.
Awesome. Very helpful. All right. Well, thank you, Parrot. That is all the questions that we had today. So looks like we've covered them all. Really appreciate everyone joining us today. There was certainly a lot of topics we covered, but this is great info to help you pass the exam. Now, don't forget to join us tomorrow, same time, for part 2 of this crash course. So it'll be whatever you're using to currently access this live stream, whether it's YouTube, LinkedIn, Facebook, you can use any of those platforms to, again, access us tomorrow at the same time. And we will build off of where we ended to give you the second part of this 2-part series tomorrow. Now, if you'd like to receive a notification when we, Cloud Institute, release a new Google Cloud training course or labs or really any kind of product for Google Cloud certifications, just send us your email. You can email me or message me directly on LinkedIn. You'll also be entered to win a free pass to our most popular Google product, which is the Google Cloud Certification Bootcamp. Now, this bootcamp guarantees you will achieve 2 of the most popular Google Cloud certifications, the Associate Cloud Engineer, which Prerit is giving us this crash course on, and also the Professional Cloud Architect. So the Google Cloud Certification Bootcamp from Cloud Institute will guarantee that you pass those 2 certification exams. If you're interested, certainly reach out to us and we can get you set up. And you can also be entered to win that product for free. All right. Well, we will see everyone tomorrow. Thanks again so much for joining. And we'll do this again and answer all your questions tomorrow as well. Take care, everybody. Thank you, Prerit.